See if I can finish this video faster than the first time I recorded it, because I thought it was a little long. All right, we are heading into 6.3, proving triangles similar by the rule AA. It's not what you normally think AA is. AA means angle, angle. Let's get our head in the math game, right? Angle, angle. The postulate angle, angle for similarity is if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. They may not have the same side lengths, but we know they have the same angle measures. So in this statement, in this picture, it's already kind of color coordinated for you. The way the similarity statement is written down here is just like a congruency statement, except there's no equal sign in between it with the little mustache squiggle. It's just a little mustache squiggle saying that the two triangles are similar. The order in which you write these statements does matter. J and X are both congruent, so therefore they have to match up. J goes first, X goes first. K goes second, Y goes second. That means they're congruent. L goes third, Z goes third, means they are also congruent. So don't forget about that from congruency statements from the previous section. All right, so now we're going to use that postulate in this example. It says determine whether the triangles are similar. If they are, write a similarity statement. Explain your reasoning. So under solutions, where we're going to show all our work. So we have this tiny triangle. C has the measure of 26. D has a measure of 90. That's what that little box is for. E, we don't know. A little question mark. Then we have this larger triangle. K, we don't know. H is 64. And G is 90. So we already know if they are similar, D and G are congruent right off the bat. They're both 90-degree angles. So I'm going to just get a little head start on my similarity statement, and I'm going to put D and G because they are matching up already. C is 26 degrees. I don't know E. H is 64 degrees. I don't know K. But I'm given two measures inside my triangle. So is there a way that I could find the third missing angle? Hopefully you wrote something along the lines of subtracting the two given angles from 180 degrees, because the total inside both of these triangles is 180. So I'm going to, for the big triangle, subtract 180 minus the 90-degree angle minus the 64-degree angle. And I am, in fact, left with 26 degrees. So that means K has to be 26. I could have done it for the smaller triangle and subtracted 180 minus 90 minus 26, and I would have been left with 64. Whoa, dyslexia kicking in a lot. There we go. So that means angle E and angle H are the same measure, and angle C and angle K are the same measure. So when I start writing my similarity statement, I want to match up the appropriate angle. So I already said I'm starting at angle D, which is 90 degrees. I'm just going to head towards E, which is 64 degrees, and finish at C, which is 26 degrees. So that means for this bigger triangle, I have to go in the same path, G, H, K. Now here, these two triangles are a little bit different. We got to use some previous knowledge from previous chapters in order to prove that they are similar. So here in example A, it says ABE and triangle ACD could be similar. We got to prove that they are. So I have these two triangles, ABE, this tiny one, and then this larger one, ACD. So I'm just going to detach them. Here's my tiny triangle, BAE, and this angle's 52 degrees. Then my larger triangle, best of my ability here, AC, not, oh my gosh, there we go, C, which is 52 degrees, and then this angle D. Well, they both share this B and C, which is congruent. So angle B and C have to be the same because they both are 52 degrees. And angle A, they both share angle A. A literally in the smaller triangle lays on top of the larger triangle. It overlaps. Well, that's pretty good. They almost are exact for my drawing. They overlap. So that means both A's in both triangles are congruent. I don't know exactly what the measure is, but I know they are congruent. And it's a fact. So I can prove these true by AA. And now I have to write my similarity statement, which they already did. A matches with A in the other triangle. B matches with C. So that means E has to match with D. Now in example B, this is a really good example because those little red play buttons or little triangles on the line, they're from chapter 3, which was when we had transversals and all that. So these two lines are parallel. That means these lines cutting right through are our transversal. So I'm just going to look at one of them as if it's like this. I already know that SVR is congruent to UVT, because these are vertical angles. But now I need to figure out, using that transversal, what else is congruent? Well, this angle S and this angle U has to be congruent because they're alternate interior. So to give you a little imagery on the side without the other lines, that's what that looks like. So angle S is congruent to angle U because they're alternate interior angles. So when you see those little play buttons, they're not there just because they feel like putting them there. It means they're parallel. And if there's a line going through both of those lines with the play button, that means that's a transversal. So we got to remember those rules of corresponding, consecutive, alternate interior, alternate exterior. So these two triangles are congruent based on the fact that there's a vertical angle that we can use and an alternate interior angle that we can use. All right, looking at these, we have to write a similarity statement if they are similar. Triangle FGH and triangle RQS. Well, this one's a little tricky, right? Because in this tiny triangle FGH, there's only one tally mark, and in the larger triangle RQS, there's two tally marks. But all of them are the same. In the small triangle, they all have one little tally mark, and if they're all the same and there's 3 angles in here and the total is 100 degrees, each angle has to be equal to 60 degrees. And in the larger triangle, again, now there's 2 tally marks, but it's consistent throughout the triangle, all 3 angles. So they have to be 60 degrees each because the triangle can't exceed or can't be less than 180 degrees. So these are true by angle. Since they're all 60 degrees, it kind of doesn't really matter which one you match it up with, but I would just use what they gave us. Triangle FGH is similar to triangle RQS. All right, my second example over here, triangle CDF and triangle DEF. So I know this is 90, and what type of angle relationship are these two, right here and right here? They are linear pairs. So if one side is 90, the other side is 90 because they're equal to 180 degrees. This angle is 32. This one is 58. Just like in the first example, I need to find that third angle. So what are we going to subtract it from? 180 degrees. So let's make sure that this does match up. We got 180 minus, let's try for this triangle on the left, 180 minus 90 minus 32, I get 58. So angle D is 58 degrees. So that must mean in this triangle, angle D is 32 degrees. 32 and 32. 58 and 58. 90 and 90. So when I write my similarity statement, triangle, I'm going to start with a bigger triangle, starting at yellow, going to green, ending at purple. F is similar to triangle, starting at yellow, going to green, ending at purple. D, E, F, which just happens to be the same way that they wrote it. Here is a little standardized test problem. Multiple choice. A flagpole casts a shadow that is 50 feet long. So here's your flagpole. Here's the shadow, and the shadow is 50 feet long. At the same time, a woman standing nearby who is 5 feet 4 inches, 5 feet 4 inches, casts a shadow that's 40 inches long. How tall is the flagpole? So this is what we want to know. How would you set up your proportion? So because we're talking about feet and inches here, I'm just going to convert everything into inches. So I'm going to have the height over the shadow. The height of the woman, 5 feet 4 inches, is 64 inches over 40 inches over her shadow, is equal to the height of the flagpole over the shadow of the flagpole, which is 600 inches. And then I'm going to cross multiply. When I do that, I get, let's see, a big number, because 64 times 600 seems like it's going to be a pretty big number, 38,400. And I'm going to divide that by 40. Now this is in inches, but all my answers are in feet. So I have to divide this by 12 inches, which gets me 80 feet. So C would be my answer. All right, you guys are going to do the even numbers in this problem. I'm going to go through the odd problems with you. So I'll start, obviously, 9 is an odd number. So here I have two triangles. We have to determine if they're similar using AA, and then we have to write a similarity statement. So I already know H and J are similar because they're both 90, or congruent because they're both 90 degrees. I need to find these missing angles, and I have to see if they have a match, another pair. So I'm going to subtract 180 minus 90 minus, let's look at the left triangle, 48. When I do that, I'm left with 42, which I get in that missing box. So if I do the same thing to my other box, angle, oh my gosh, little corner. When I do the same type of math for the smaller triangle, and I subtract it all, I get 48 degrees.
I don't know that one.
Well, that's weird because I didn't talk to you, Alexa. Never mind. Did you guys hear that? She just turned on. That was creepy. And I got it on video. Strange. All right, let's write our similarity statement. So I'm starting at angle G, which is 48 degrees, and it matches with angle L, which is 48 degrees. F is 42 degrees, so is K. H is 90, J is 90. So I'm going to start at yellow, head to green, end at purple. Yellow is G, F, and then H is similar to triangle, yellow, green, purple, L, K, J. All right, you guys tell me if these two triangles are similar for number 10. Number 11, I gotta find out the missing angle. So I already see that S and T are congruent. Let's figure out if R and V are congruent. So I'm gonna subtract from 180, 85 minus 35. I end up with 60 degrees right here. So these two are not congruent and not similar because only one angle matches up. All right, you guys, try number 12. Are they similar, yay or nay? And then what is your similarity statement? If they are similar. Number 13. I have two triangles very similar to number 12. I have two triangles that overlap on each other. Y, X, Z. I'm just going to detach down here. This is 45. This is 85. And then I have my larger triangle, Y, U, W. This is 85, and this is 50. So we already have that both Y's are congruent. Duh. They overlap. They have to be. Now I need to find that missing angle, and I got to see if angle Z is congruent to W and angle X, which is 45 degrees, is congruent to angle U. So do the only math that we're doing in this section and subtract 180, calculator 180, minus 85, minus 50. I get 45. So that means this angle and this angle are congruent. Let's use my colors because it makes things easier. So that means that third angle has to be congruent. They have no choice. So my similarity statement, I'm going to start at yellow, go to green, then blue. Y, X, Z is similar to yellow, green, blue, Y, U, W. Last but not least, I want you guys to give this one a shot before I explain it. Is it similar? Yay or nay? And then what is your similarity statement? So since I have two triangles here that are overlapping, I'm just going to detach them. It's what I do best. Redrawing triangles. And I can already see when I'm rewriting them and detaching them, I'm putting n twice. So that is an obvious statement that n is congruent to n. Now we got to look at these parallel lines. So here's a parallel, and there's its match. That means this line going through it is a transversal. And so is the other line that's going through it. I'm just looking at this one. Since that is a transversal, make it bigger over here. This angle on the inside and this angle on the outside are corresponding. Corresponding angles are congruent. Therefore, I can say angle L and angle M are congruent because they are corresponding angles. So my similarity statement, I'll put the colors back on, then we can assume Q and P are congruent. Go to yellow, green, blue. Yellow, green, blue. So triangle LQN is similar to triangle MPN.